Hey everyone, I'm Gareth Baars, founder of Intent Architect, and in the next 60 minutes, I'm going to show you guys how you can write enterprise-grade software applications in C# and .NET in a fraction of the time without having to write a single line of boilerplate code yourselves. I'm going to introduce you guys to some of the key concepts and revelations that we had as developers that led us to create Intent Architect in the first place. And of course, I'm going to introduce you guys to the platform itself in a comprehensive introductory demo. At the end of the webinar, and with all the hype around AI in the industry at the moment, I'm also going to give you guys a sneak peek into how we can leverage generative AI, integrate it into the platform to accelerate our coding even further. So be sure to stick around until the very end. Now, before I dive in, I know many of you joining today are already users of Intent Architect, and some of what I'll be covering might therefore be quite familiar to you. In this session, however, I want to take a step back to show everyone, especially those seeing it for the first time, how we can build these high quality applications with such efficiency and accuracy. So for those of you who don't know me, I'm the CEO and one of the co-founders of Intent Architect. I have an engineering background. I've been building software systems for well over 20 years now. I spent a couple of years as a solutions architect for one of the top software consultancies, and then I spent a few years as a CTO for a tech-enabled SMB before I went full-time into this business back in 2018. So long story short, I've been in the trenches and I've seen firsthand the many challenges that dev teams face on a day-to-day basis. So on that note, that's exactly where I want to start the conversation with you guys today. So I'm going to just jump right in and start sharing up some slides. All right, so as mentioned, where we really like to start the conversation is by looking at the challenges that teams face in the software industry. And these are very universal, so pretty much common to all the teams that we talk to. And I'm sure you guys are very familiar with a lot of these. But before we get into exactly how we address these challenges, I want to first share with you a key realization that we had over 10 years ago now. And that is that between 35 and 85% of the code base related tasks that we're doing as developers on a day-to-day basis are actually predictable and repetitive. And to understand this better, it does help to take a look at a few examples. So if we look at a backend system, as an example, built in .NET Core, we'd most likely see a lot of controllers, right? And each controller, if we look at the code within that controller, is completely unique to the system. But if we look at all of those controllers collectively, we would see that they all follow the same implementation structure, and we can call that structure the controller's pattern. Very similarly, if we looked at all the entities in the system, we would see that each entity in the system is completely unique too, in terms of what code is written there, but they also follow the same implementation structure, and we can call that the entities pattern. And what these have in common is that they both follow the same they both follow a set of implementation rules, and this is what makes them predictable. And they're required for every service or domain object in the case of the controllers and the entities, respectively. And that's what makes them repetitive. And so a pattern can rarely be defined in the coding space as anything that is predictable and repetitive. And if we zoomed out, we would see that these predictable and repetitive patterns exist all throughout our architectures. And this is, of course, by no means comprehensive. This diagram is just a typical subset for illustrative purposes. There are many, many predictable and repetitive patterns that make up our architectures when we're building out our software applications these days. And because so much of the code that we write falls into this definition of predictable and repetitive, it actually presents us with a massive opportunity, and that is an opportunity for automation. And what we found is that the most effective way for us to bring this automation into our software development on a day-to-day basis in a way that's powerful, comprehensive, but also practical is through a mechanism which we call pattern reuse, which is very, very core to what we do and very fundamental to what we do at Intent Architect. So I'd like to just jump into introducing you guys to this concept or mechanism very quickly. So the first thing I could say about pattern reuse is that it is what we see at least as the missing tool in the developer's toolbox. And the reason we say this is because, as you guys can imagine, we are talking to hundreds of developers and teams all over the world. And this is something that we almost never see any of these teams having access to. The second thing about pattern reuse is that is essentially the building block for architecture reuse. So this is the ability for us to reuse architectural components across our projects, and that is ultimately the end goal, right? And so pattern reuse is essentially the building blocks for us to be able to do this. So let me run you guys through how this works at a high level. We've talked about these patterns, these predictable and repetitive coding structures in our systems. Pattern reuse is the process of taking these predictable and repetitive code structures, codifying them into artifacts of pattern reuse, and then using automation. And this is, by the way, where a lot of the sophistication in our approach comes in, which I'll show you guys later in the demo. We use automation to essentially roll these patterns out into the code base. Now, because each instance of the patterns, each controller, each DTO, each repository, each entity, et cetera, throughout the system is unique, we need a way to drive this. And so the way that we drive it is ultimately through models and metadata, which essentially represents the design of the system. You could think of it like a set of blueprints that explicitly describes how the system is designed at a high level. And we've been applying this process of pattern reuse to building out software systems for well over 10 years now. And we've seen the same benefits from this process happen each and every single time we've applied it. And I can run you guys through those at a very high level. So the first thing we're able to gain is huge efficiencies and time savings. And the reason for this is simply because we're automating the vast majority of the predictable and repetitive work, which would typically include most of the boilerplate coding that we as developers were going to have to do in any case. The second thing is because we could do this so comprehensively, we're able to knock out the biggest cost in building out the systems, which is the architecture. So we get what we refer to as a free architecture. And then very importantly, this mechanism of pattern reuse brings in standardization, consistency, and architectural adherence into the code bases by default. This is something that is also maintained by through pattern reuse. So it maintains the standardization, this consistency and architectural adherence over the lifetime of the project as it evolves with new use cases and shifts around in its design. So this is where we see a huge quality boost to the applications built with this mechanism, as well as a lot of other fringe benefits that we could talk about a little bit later. And then pattern reuse allows us to retroactively upgrade the code bases to accommodate for the various inflection points we typically have on projects. So this is where, for example, we could upgrade to the latest version of technologies. We could upgrade to the latest patterns that teams want to follow and keep everything consistent. And so you get what we call code base upgradability through this. It doesn't really matter whether the code base is 10,000 lines of code or 10 million lines of code. The upgrade path is constant and very, very easy for teams. Another term we like to use for this is an agile architecture, which is really, as I'm sure you guys all know, the opposite of what most teams experience when they're building out software systems, because the larger those systems become, the more rigid the architecture becomes and the more difficult it becomes to make changes. And pattern reuse essentially eliminates that problem for us. And then the final thing that pattern reuse brings to the table is because of the models and metadata, we're able to ultimately self-document the systems as a set of blueprints that the team can then use to collaborate and understand the true design of their software systems explicitly, as opposed to reverse engineering the design out of the code. And this is something that really helps teams with decision-making and keeping everybody on the same page. It helps with ramping up new joiners and moving team members around so when we need to access different parts of the code base. So that's just a quick introduction to this very, very key concept called pattern reuse. Next, what I want to do is I want to give you guys an overview of Intent Architect, the actual platform itself. And then after that, we could jump right into the demo. All right, so what is Intent Architect? First and foremost, it is a platform for pattern reuse. So it's essentially a place for developers to automate any predictable and repetitive patterns wherever they choose. We also refer to Intent Architect as a next generation code automation platform. And the reason we call it next generation is really what I will be showing you guys in the demo in a few minutes. And then I'm sure it's clear for you guys, but this is a platform for developers to help them build out their line of business applications. And it's also configurable and extensible. And this is fundamentally what makes it a platform at the end of the day. Then, just so we're on the same page, we're not a low-code platform. I'm sure you guys are familiar with tools like OutSystems and Mendix and Salesforce and Appian and maybe Power Apps and those kinds of things. We are not a low-code platform. We are 100% orientated around high-level programming languages, their frameworks, technologies, and ultimately the architectures that build up these applications. We are also not a scaffolding tool. So maybe you guys have some experience with things like T4 templating or maybe JHipster or some Visual Studio solution templates and things like that. Those also do some level of code generation, but it is so basic and so rudimentary in comparison to what we do that we do not consider ourselves a scaffolding tool at all. And then very importantly, we're not a framework. And what we mean by this is that we don't actually have a set of NuGet packages, for example, that a team has used in order to build out an application with Intent Architect. So unlike an ABP, for example, we don't introduce any runtime dependencies into any of our clients' environments. And so what that means is that when a project is built with Intent Architect, there is zero lock-in whatsoever. And that's something we're actually very, very proud of because our clients are with us and have stayed with us for all of these years because of the value that we can constantly bring to their development teams on a day-to-day basis, knowing that they can walk away from us at any second of the day, since there is absolutely no lock-in when building out a system with Intent Architect. And then the final thing that I can mention here is that we're not a prescriptive platform. And what we mean by that is that different applications require different architectures, different technologies, different patterns, and so on and so forth. And we do not prescribe on a team or on a project what patterns and architecture they should use. Intent Architect can fundamentally be configured to automate any architecture. And then the final thing that I want to take you guys through just before we jump into the demo is how do we actually achieve pattern reuse with Intent Architect? And there are essentially three mechanisms that we use to achieve it. And I'll be doing a deep dive as part of today's demo into each of these mechanisms today. So the first mechanism is modules. Modules are the artifacts of pattern reuse in the Intent Architect ecosystem. You could think of them like the pattern. So a module represents a pattern fundamentally, and because any application can be configured to use a completely unique set of modules, it's through the module system that we can accommodate all of the different patterns, standards, technologies, and ultimately architectures that teams could want to follow for their different applications. So it's very, very key to the versatility in our approach, and I'll be showing you guys a lot of examples of modules in a few minutes. The second mechanism that we use is code management. And code management is part of that next generation advanced language support that I mentioned earlier. And if I had to really simplify what code management is, it's a system which allows us to tell Intent Architect which parts of the code base are managed by Intent Architect and which parts of the code base are managed by the developers at a very fine-grained level of control. And this is something that the developers can shift around and reconfigure very, very easily as and when they need to. So this is a very, very key mechanism because it essentially protects the code base from becoming convoluted, and it ensures that we can always customize and follow best practices when building out the systems and coding out the various use cases. So it's very, very core to the practicality of our approach. And then the final mechanism that we employ is our visual modeling systems. And we have very, very powerful visual modeling systems in Intent Architect. And I'll be able to show you guys quite a few examples of these in the demo too. So that's a quick introduction to the platform, guys, and the key mechanisms. Let's jump right into the demo. All right, great, guys. Let's jump right in. I'm going to launch Intent Architect. And the first thing that you guys are going to notice is that this is an application that is installed on my local machine, right? So I'm running a Windows machine. A very common question we get is, do we support Mac and do we support Linux? The answer is yes. We have builds for all the major operating systems. The second thing that you'll notice is that this is version 4.4.3 of Intent Architect. To give you guys an idea, we've been building this platform since 2015. We've had a dedicated team of some really smart engineers that have been building this out over the years, and we have far exceeded what we originally set out to achieve as a business. So I'm really excited to take you guys through this particular version of Intent Architect because it's got a lot of very, very cool features that I'll be able to show you guys today. Just to orientate you very quickly, here's some links to our documentation. We've got quite a lot of docs on how to use Intent Architect. And then this is quite arbitrary. This is really depending on the user, but these are just the most recent applications that I've had open on my machine. And then we've got the two starting blocks. We can create a new application. This could be a new monolithic application. It could be a new microservice, maybe the first of many. It could be a new front end. It could be just a folder on the hard drive where I want to do some automation. So it really could be anything where we want to do some code generation and code automation. The second starting block is to create new modules. So as I mentioned earlier, modules are a very, very key concept and a core mechanism in Intent Architect. And we have inside of in the system, we have a module building ecosystem for Intent Architect. And what this allows is it allows any developer using the platform to automate anything predictable and repetitive in their environment. So they're able to automate patterns as and where they see them in their environment. And this is something that is quite popular with a lot of our users. I would estimate that about a third, at least, of our users actually get into module building. Unfortunately, there isn't enough time as part of today's demo for us to go through this, but we did do a webinar a while back, which did an introduction into module building. So if you guys hop over to our YouTube channel, you guys should be able to find that webinar. So if you're curious about that, But this is something that is done by a lot of teams, and really because the return on investment for creating patterns and automating patterns as modules is usually like 100 to 1,000-fold within the first year. So it's something that is usually very, very valuable for teams as and when they create those. All right, so let's get right into it. I'm going to create a new application as part of today's demo. I'm going to use a clean architecture in .NET. I hope that that's quite familiar. If you guys aren't familiar with this architecture, it has been gaining huge popularity in recent years. In quite a few years, in fact, that we've seen this really emerging all over the world. It's very, very popular. And let's just call this webinar. And what we'll be creating today is we'll be creating an ordering system. So let's just say it's either a microservice or a monolith to support an eShop. We like to use that domain because everyone's familiar with that. Like I think everybody's worked, done a checkout on Amazon, for example. So we like to use that for these kinds of demos. So I'll create a webinar.orders application, and we'll just call our solution name the webinar. Before I move on, you'll see that there is this checkbox over here that says store intent architect file separate to the code base. Now, the reason I want to point this out is because earlier I was talking about blueprints, right? And those blueprints represent the design of the system explicitly. And what this is really alluding to is that those blueprints are in fact persisted on the local hard drive of the developer. And what that means is that, number one, they're not sent off to some third-party server in the cloud where you have to worry about what happens if that database where it's stored on gets hacked, because those blueprints are undoubtedly intellectual property of the business. And you certainly don't want those to be exposed in any shape or form. And so because we can also store these on the local hard drive of the developer, we can check these into version control separate to the code base, but within the same repository. And so what this ultimately means is that the security of those blueprints is set at the same security as the code base, which is something that's been incredibly important for the corporates, the insurance companies, the banks, and so on and so forth that we work with. But it's pretty important for all of our clients, and that's really why I wanted to just mention this as part of today's webinar. All right. By the way, these are application templates. These are ones that our team has created. They're all open source. In fact, all of the modules that I'm going to be showing you guys today are all open source. So if you head over to our github.com/intent architect, you will see all the repositories there with all of the different open source modules. And you can, of course, this is something a lot of teams do. A lot of teams could go, will actually go and create their own application templates, which is really just you could think of it like an architecture template, where you can essentially pick and choose from a set of options of architectural components that you'd like to use, and you can have it pre-configured around the application and the way you like to structure things. So that's also very, very popular with our clients, is to set up these application templates. I'll just be using one of the open source ones that our team has created for the clean architecture over here. All right, so I'm going to say next now, and now we're going to jump into the, this is taking us into the clean architecture and all of the different architectural components and the options. You guys will probably be quite familiar with all of this. So we can run through these very, very quickly. I'm sure this is all quite familiar to most .NET developers. So we've got things like ASP.NET Core for our web API. We've got Swashbuckle for our open API. If we need WebSockets, we can bring in SignalR. If we don't need it, we don't need it. Health checks, if we have infrastructure for that. On the application side, we've got the mediator. So this is just a very popular Jimmy-Bogart pattern that follows a CQRS design paradigm. And then you've got the typical application services. A lot of teams, this is, if you're not familiar with the mediator, this is actually also a library and a pattern that's become immensely popular in the .NET space with teams all over the world. We've seen it really just growing in more and more popularity over the last few years. And application services is pretty much how teams used to do things before that. But a lot of teams are using both of these. Some teams pick and choose. It's really just up to the team. They're both compliant with a clean architecture fundamentally. Automapper, that's for mapping entities to DTOs, fluent validation for validating incoming requests. You'll see that these represent patterns that are backed by technologies, right? Like Automapper or Mediator. It's the pattern that we're automating here is the code that is using that technology, as you guys will see as we get into the demo in a few minutes. Then we've got these two modules here. These modules are a little bit interesting. So I think let me just explain a bit more here. These two modules are essentially able to automate the predictable and repetitive business logic that is orientated around the flow of data in and out of the system. So the creating, reading, updating, and deleting of data, or CRUD-related aspects of our system, that business logic that is required to do that is actually very, very predictable and repetitive, and so we can automate that. And these modules are able to do that for us. They're also very, very powerful because what these modules are able to do is they're able to work with both an anemic style of domain development as well as with a rich domain style of domain development. So we've got quite a couple of clients that do very, very strict DDD, for example, and these modules are able to support them just as well as it's able to support the more anemic style of development. Pagination, I think nothing needs to be said about that. Same for entities. Value objects, if you are doing DDD, value objects, domain services, maybe you're not, so maybe you'll leave these out. Maybe you don't want domain eventing. You can go check out our webinar on some of these patterns. We've also got one that we did a while back that's around things like domain eventing and how to build out rich domains. For persistence, we're just going to use Entity Framework Core, but of course, we've got patterns already available out the box in the open source repositories for most of the other persistence paradigms. Same for security. Of course, can you automate tests? If it's predictable and repetitive, it can be automated. And so this is an example of a module that essentially automates integration tests. So this is something that, by the way, our team really values. We love this particular module because it does a lot of the checking of the glue within the systems to make sure that everything is always going to be working. Then if you're building microservices or you need some kind of integration, of course, you're going to need some kind of pub/sub. Mass transit, very, very popular for that. Comes with all the bells and whistles, the exponential backoffs, the outbox patterns and inbox patterns, the item potency checks, all of that kind of stuff. So very, very popular there. HTTP clients for service-to-service invocation. Of course, if you want to use gRPC, that's also perfectly fine. Kafka, the other options, the Azure Service Bus, those are all there. These are just very popular options that teams will pick and choose from. And so these are the ones that are listed over here. Finbuckle for multi-tenancy, different security management, what kind of logging and telemetry patterns we want to bring in, any kind of object storage for cloud that we want to bring in over here, and other tooling. So this is just a very, very popular set of patterns that teams pick and choose from when they're building out microservices or monolithic applications with the clean architecture. So any decision I make at this point, I can change later. So if I'm happy at this stage, I can go ahead and say create. And what this is going to do for me is it's going to set up my solution called webinar, and it's going to create our first application here called webinar.orders. And what it's doing in the background is it's actually downloading and is caching all of these different modules for us. So one thing that I could just mention here is that, and this is just because it's sometimes a confusion point when we do the demos, is that these here, let me just pull this up again so it's a little bit more clear for you guys. These are not NuGet packages, okay? These modules that are being restored, these are modules. These are artifacts of pattern reuse. So taking a step back here, if we have some code that we write, if we're on a team and we write some code, we want to share that code across our projects, we could just take that code, especially if it's exactly the same code that we want to share each and every single time, we could just turn that code into a NuGet package. And we can version it up and we can distribute it and we can use that on all of our projects going forward. And that is the essence of code reuse, right? And we want to use code reuse as far as we can, right? But code reuse has a limit because the code has to be exactly the same each and every single time when we deploy it. And so when it comes to code that is not static like that, but it is predictable and repetitive, that's when we can leverage pattern reuse and artifacts of pattern reuse to essentially automate the generation of that code, the generation and management of that code. And that's what these are. These are artifacts of pattern reuse, right? So I just wanted to make sure that's clear, just because that is sometimes a confusion point during the demos. All right, guys, so we've got our first application over here. If I was building a microservice architecture, I may need to create another application. If I wanted to, I can make it another clean architecture. That's perfectly fine. If I'd like, I can make it use Cosmos DB or MongoDB or something like that. I can even go as dramatic for my next application and as making it switch languages completely and using a completely different tech stack, like, for example, Java Spring Boot. And so the reason I'm showing you guys this is because really when it comes to different applications, each application that Intent Architect that you're using Intent Architect to build can run a completely unique architecture, right? Even so dramatic as to be running in completely different languages. And that's very, very key because, well, I mean, just as an example in the microservices space, as you guys would know, part of the appeal of microservices is that you can optimize different services to meet the non-functional requirements of that service. And you can optimize the architectures of that particular service to meet those non-functional requirements. And so that's a very, very key and core concept in Intent Architect, is that the architecture of a particular application will be determined by the modules that you install for that application. And it's not something that is preset that applications must follow a particular architecture. So if we want to see for this particular application what modules are installed, we can click on Manage Modules over here. If we click on Installed, we can see the actual modules that are installed for this particular application. You guys will recognize a lot of these because we saw them just a few minutes ago. We've got the automapper, the DTOs, the pagination, that's the mediator behaviors. There's the ASP.NET Core. There's our controller pattern. So we spoke about that earlier on as the example that we gave. And this is the pattern that, by the way, that dispatches from the controllers to the mediator. And this is the pattern that dispatches from the controller endpoints to the application service contracts by dependency injection, right? So if you guys are filling that in, I'll obviously show you guys what that code looks like in a few minutes. Health checks, ASP.NET Core versioning, entities, repository interfaces, entity framework core configurations. This is the repository concretes that use the EF core, and so on and so forth, right? So if you don't recognize any of these, don't worry about it. The purpose of today's demo is not really to go into the clean architecture. We did a webinar on that too, so you guys can go check that out on our YouTube if you guys are interested. The purpose of today's demo is to really give a comprehensive introduction to Intent Architect and to show you guys the mechanism of pattern reuse in action, right? So the other things that you guys will notice here is that if we look at any particular module, that module also has different versions. Now, once again, these are not versions of the NuGet package. These are versions of the pattern. So just as a quick example, let's say that a team has built out an application, and that application was quite a large one. Now, it been built for several years with a substantial team, and it's over 1 million lines of code, and it was using automapper, right? And let's say for whatever reason, Jimmy Bogart, who's the author of automapper, decides to change his API completely because he's had some new revelation, and we on our team want to upgrade to this latest version of automapper. So we go into our NuGet package manager inside of our code base, and we go and we update to the latest version of automapper. What would we likely see throughout that application? We'd probably see thousands, if not tens of thousands, depending on the size of the application, of compile errors throughout that application. And we would have to correct each and every single one of those ourselves as developers in order to make the upgrade. And this is why it becomes, the larger the applications this is why it becomes more and more rigid and difficult for teams to stay up to date with the latest technologies, is because that cost of making these upgrades, especially when there's API changes, the cost of doing that is oftentimes prohibitive. What we could do with Intent Architect, to give you guys a bit of contrast here, is we could just create a new version of the pattern. Maybe we can call that version 6 of the automapper pattern. And that, let's just say that version 6 is also now compliant with Jimmy Bogart's new API. We can then just update our application. It could be several years into building this application. We can upgrade it to version 6. We can run the software factory execution, which I'll show you guys in a minute, and we can essentially upgrade that entire application and fix all of those places where we're using the automapper. We can get all of those upgraded pretty much in a matter of a few seconds, right? And so that's how we start to achieve what I was talking about earlier when I was talking about code base upgradability and an agile architecture. The other things that you guys will notice here is that we can also remove patterns. So it may come, a team could realize, geez, automapper is actually quite inefficient. We should be using direct mappings, or we should be using something like Mapster. We can remove patterns at any stage during the life cycle of the development. So even years in, we could say, well, let's get rid of automapper and let's swap it out for something else. I did hear that Jimmy Bogart was thinking about commercializing some of his frameworks. That wouldn't be a problem from an Intent Architect perspective, because we'd be able to swap most of that out just in a few minutes, most of the teams. And we can also, we can remove patterns, we can upgrade and downgrade patterns, and of course we can install patterns. So if we realize down the line that actually we don't want to use a controller pattern and would rather use a fast endpoints pattern, we can go and uninstall the controller patterns and replace that with the fast endpoints. If we realize we need some kind of caching, we can go and introduce like some kind of Redis caching for ourselves. Maybe we realize we want to bring in that mass transit, we can bring in mass transit. And so we can bring in any pattern, we can browse for these patterns, and we can do this also at any stage during the life cycle of development. Now, through these mechanisms, being able to add patterns, being able to remove patterns, being able to upgrade and control exactly what version of a pattern we are running, this is essentially the core mechanism for us to be able to get this code base upgradability and to have these agile architectures all the way through into the late maturity of the projects, especially when they become very, very large. So right at this stage, if it's not clear for you guys, there is in fact no code base at this point. So if I want Intent Architect at this stage to act on the code base, I need to run the software factory execution, which is what I was alluding to a bit earlier. And what you can see here is that when I kick off that software factory execution, I'll just kick it off again here so you can see it. What it does is it does processing. It's processing the installed modules at the version in which they're installed. And once it's finished processing, it moves into the next step, which is what we call a staging. And the reason we call this a staging is because none of these changes have actually happened yet. Intent Architect is actually presenting this to the developer saying, hi, developer, these are the changes that I would like to make to the system. And so this is part of our core philosophy, and one of the core principles we follow with Intent Architect is that everything should always be transparent for the developer. And so we have these stages changed for the developer to decide whether they are happy to bring these changes directly into this code base. And so we never have this, surprise, your code base got changed and you're trying to figure out what just happened there in the background. If the developer is not happy with these changes, they can shut the software factory down. At this stage, there still is no code base. If I try and open up the output location, it's going to tell me even this folder doesn't exist. Let's rerun the software factory execution. Does the same processing. It lists out the same files. They're green with a plus. That's because these are new files. And I'm sure you guys would agree with me. It's not really useful for us to be able to just see these files at a high level. We need to know what's going on inside of these files. So if I double click, for example, this program file over here, it's going to open up for at least me on my machine. I've configured up my instance of Intent Architect to use Visual Studio Code. I just like this as a diff tool. And here we can see the actual code that Intent Architect is going to roll out for us. So on the left, here's the code base. There is no code base. That's why it's blank. And on the right is what Intent Architect wants to do. We call this the projection. So here you can see this is a very standard program, minimalist startup, essentially. There's our DI configuration. There's our HTTP pipeline configuration. And I can take a look through some of these other files here. We're not going to go through all of them, obviously. Like I said, the purpose of today's session is not really to get into the architecture. This is just the DB context for the application using just the standard Microsoft DB context. So as I mentioned, there's no special framework that a team must use here to use Intent Architect. It's all the open source industry best practice frameworks and technologies. The other thing I could just point out for you guys here is that we're not really limited to automating only code files. We can automate any text file. In fact, we can even automate binary files as part of the software factory executions. And so here's just a simple example of a JSON file. And one thing I could mention is that very, very common use case for a lot of teams, especially in microservice environments, is that a lot of teams will use the module building ecosystem to automate their CI/CD pipeline configurations, deployment configurations, OCL files, HCL files, those kinds of things, YAML files, and they will automate all of that. It's usually very, very low hanging fruit because it's usually very, very predictable and repetitive. And the reason a lot of teams do this is because it's so easy to get that kind of thing set up. And then you essentially have an application, whenever you spin up a new application or a new microservice, it is pretty much instantly deployable as soon as you create that application. So that's just an example of where teams oftentimes use things like the module building ecosystem. All right, so we get some stats here from the software factory execution. So if we're happy with all these changes, we can say apply changes. And now we actually have a code base. So if I open up the output location, here's our code base. And if I double click this, it'll open up Visual Studio. And we could just wait for that to load. While this is loading, just by the way, if we take a step back, you'll see here that we've got our webinars folder. And inside of here, we've got our application. Inside of this folder is pure code. So if I had to zip this up or check it into a GitHub repository and share this with you guys, you would be able to check out this code base right now and compile it. As I mentioned, there is absolutely no special framework here that you need to have access to in order to run this. So this is all pure code. Then in this folder over here is all the Intent Architect files. So this is where the blueprints would be persisted. It's inside of these folders. And because these folders, this is separate. Some teams like to put this folder inside of that folder and things like that. That's completely configurable. But what we would typically do is we would check these into the same repository. So if I wanted to, I've just got Tortoise Git here on this machine. I can go create a repository here, for example, and I can have my Git repository to check both of these in together. And all the Git ignores are already there for us because we had that checkbox selected a bit earlier. Now, guys, I'm sure you'd agree with me at this point, if we take a look at the solution, that all that we've actually really done is we've just bootstrapped this application. So, it's really just getting it ready to go. What I want to do next is I want to get into actually making this turning this application into something that actually does something for us. So I'm going to start on the domain. Earlier, we said we were going to be building an ordering system, right? So you guys will probably be familiar with that kind of a domain. That'll be things like an order with line items, and those line items will be pointing to particular products with number of units and prices and discounts and all of those kinds of things. And typically what we see and what we've seen, even before we worked with Intent Architect, is that when teams get requirements from the business, and especially if those requirements are of a substantial level of complexity, is what we see teams typically do is that they would go off to the whiteboard and they would start to model out their domains, their persistence, their services, and the events that they want to publish and subscribe to, maybe the other amount of context or microservices that'll be involved in the solution. And they'll do all of this on the whiteboard, or some teams do it in UML modeling tools and things like that. We can do all of that design work actually directly inside of Intent Architect. So coming back to our ordering system, we can just start modeling this out for ourselves. So I could start by creating myself an order, and I can say, well, I also like an order line and a product. And I can go and just lay this out nice and neatly for myself. And we can just put well, actually, I want to just select there. I want a many-to-one, no, I'd like a one-to-many relationship, a one-to-many relationship between the order and the order lines. And I would like a many-to-one relationship between the order lines and the products. On the order itself, I can just fill in some of the details here. So let's have the order number and the order date, which I'll make a date time. And on the order line, I'll create the number of units, which will be an integer, and maybe the units price, which will be a decimal. And maybe let's add a discount to this too, which will make a decimal, and I'll make this a nullable. By the way, I'm just using some shortcuts here just to speed this up for us. There's a lot that we want to cover on the product name, description, price, make that a decimal. And we want let's say an image URL as a string. So like, what image do we want to show for this product? So we'll just stick to a very simple domain, just modeling out mainly what we want to persist at this stage. And if I push save now, what you guys will notice is that software factory execution that I'd opened earlier has been minimized to the taskbar. And every time I push save, it kicks it off in the background. And once it's finished processing, if there are changes that it wants to make to the underlying code base, it'll start to flash. And right now it's flashing and saying that there are 11 changes to the code base that it would like to make. And so here we can see that, of course, as we modeled our domain, it's going to bring us our entities, our repository interfaces, our repository concretes. This is the entity framework configurations. Here's our dependency injection and changes to our application DB context. By the way, these different colors, these are edits. These are changes to existing files. And as I mentioned earlier, the green files here are new files, right? So we can actually take a look if we're interested in what these edits are doing. On the left is the code base, and on the right is the projection, as I mentioned earlier. And so we can see here what Intent Architect wants to do is it wants to go and set up our DB sets for our orders and our products, and as well as just register up the appropriate configurations. We can take a look at those configurations as an example. So here's the order configuration. So there's our one-to-many relationship with the order lines, and there's our many-to-one relationship with the product. Now, one thing that you guys may find quite interesting about this pattern, just as an example, is that this entity framework pattern is used by I don't know, it's used on dozens. It's used by many, many, many teams that we work with. I can't tell you how many. It's probably hundreds of developers. Every day they go to work, they see this pattern, right, getting rolled out. Of course, probably not for orders, but for whatever their domain is in particular, they would see this pattern. And because patterns like this entity framework pattern, and pretty much most of the patterns that I'm showing you guys today, because all of these patterns and these modules are open source, what tends to happen is that there's actually a constant stream of requests and inquiries and challenges to the patterns and so on and so forth that are coming to our team, as well as some teams that are even doing pull requests on some of those modules. And so what tends to happen very, very quickly, especially on patterns that are quite popular, is that they tend to stabilize, and they get to a point where it seems pretty much across the board that all the teams and all the developers, by and large, are very, very happy with the pattern, the way it's being rolled out. And what we really like about that from an Intent Architect perspective is that we're essentially leveraging a community of developers all over the world, really, really smart guys all over the world, to help define what exactly is best practice in .NET and C#, right? And so this entity framework pattern is a great example of that, but pretty much all of the patterns I'm showing you guys today have reached that point where we would call them community verified. All right, we can take a quick look what's happening in the dependency injection. So this is obviously just registering up our repository interfaces against the concretes. We don't need to go through all these files. We can just go ahead and say apply changes. And if we come into the code base, we'll find our code there pretty much straight away. So as soon as we say apply changes, it updates the code base. And so we'll see it inside of our Visual Studio. And here you can see that our DB context is exactly as we saw it a minute ago. You'll notice everything is compiling, everything is happy. Here's our order configuration that we saw just a minute ago. There's our interfaces. Here's our repository concrete, our entities, all of that stuff in the appropriate place within our application. And so you could say at this stage, persistence is pretty much ready to go. So we can go now and we can go set up some services to act on this persistence and actually use it. All right, so let's jump into the services designer. And what I'm going to do here is I'm going to jump in and start using what we call an accelerator. Now, what is an accelerator? Because I know that I've got a pretty much developer audience today, an accelerator is quite simply a JavaScript script, okay, that instructs the intent architect designer to do some work for us, right? So it's through accelerators essentially allow you to programmatically automate work that you would otherwise have to do step by step yourself inside of the intent architect designer. And because they're just JavaScript scripts at the end of the day, this is something that a lot of teams firstly can write for themselves through the module building ecosystem, and we have quite a few teams that absolutely love doing that because they're essentially able to automate even the design work that they typically have to do on a day-to-day basis. So I'm going to show you guys. Our team's obviously created quite a few accelerators already, especially around very popular use cases, and so I'm going to show you guys just to kick this off. This one over here, which is create CRUD CQRS operations. So I'm going to click this. It's going to ask me which entity I want to create this for. I'm going to say do it for the order. I'm going to leave all of those checked and I'm going to say done. And what this is going to do for me is you're going to see it's going to create me 3 commands: a create, delete, and update command for the order, as well as a get order by ID and a get orders query, which is going to return us this order DTO and a collection of order DTOs, right? And this accelerator has also gone ahead and wired it up, all of these commands and queries, to the underlying order. And so if we go to the definition of this order, it is actually referring to the order inside of the domain. So I'm just going to navigate back. And this relationship here is a creation relationship, okay? And what Intent Architect does really well for us is that it can actually also show us the flow of data, how the data from this command, when this command is ingested or triggered into the order. And so if I just say Control Space, which is the shortcut to open this up, it'll show me that right now the order number and the order date from the command are going to populate the order number and the order date on the order inside of the domain. Maybe I look at this and I'm like, well, I'm happy with that maybe, but I'd also like to include the order lines. And I like to include all of the fields on those order lines. So I'm just going to double click my way through that and I can say done. On the update, I can do the same, but maybe when I get to the update, I look at this and I'm like, this isn't right. You should not be able to change the order number and order date because those may be immutable fields in our system, but I do want to be able to change the order line. So I'll go ahead and just wire that up and you'll see it's going to create me a new DTO here as well. All right. And so all of those have just been created for us. And then on the queries, just by the way, just in case there's any confusion here, this is a diagram, okay? Over here, you can have as many diagrams as you want, and this is a view onto the model. The model is over here on the right, and this is the truth of the system, right? So you can have different diagrams to take different views on the model, but ultimately the model is the truth and a diagram is the view on the truth. Just want to make sure that's 100% clear. If we take a look at the queries, for example, we can see that the query is going to return this order DTO, and we can navigate to that, and you'll see that this DTO is actually set with a mapping from the domain object. And we can, if I can right click here and just say, click that or Control Space as I did earlier. And this is going to show us how we're actually, or what data points from the domain we want to fetch out into this DTO. And you can see here, that's going to fetch out the ID, the order number, and the order date. But maybe I also want to include the order lines. I can say done. That's going to create me this field over here. And I could say, well, I also want to go and configure up the order lines. And you can see it's going to bring through all of these fields, but maybe I want to also include some of the fields from the product itself. So maybe I want to include the name and the description and maybe the price of the image URL too. And I can say done. So we'll just take all the fields. And what that's going to do for us is it's going to create an additional 4 fields here on this DTO, which is fetching out and essentially denormalizing that data from the domain into this flattened structure, which is maybe preferable for the clients, whatever. Maybe it's a front end or something like that. We just want to be able to send this information directly up. We don't want to have some kind of a nested object at this point. So this is, by the way, we've got AutoMapper installed, but pretty much any mapping system will make super light work of this kind of a design and this flattening denormalization that we've just described over here. All right, so let's say we're happy with that from an order perspective. Next one I just want to show you guys is I want to show you guys this other accelerator, which is to create CRUD, a traditional service for CRUD around a certain entity. And I'll do that for the product over here, and we can say done. And I just want to do this so that you guys can see these both in contrast. So I'm just going to drag this into the diagram so we can see these. And just going to lay it out just nice and neatly for myself. There we go. And what you can see here is that the difference between the CQRS paradigm, commands and queries, versus services with operations, ultimately, when we create these, we can achieve the same results, especially from a CRUD perspective, if that's what we're looking for. So here you can see the create, the delete, the update, the find by ID, and the find all products. And you can see that we've got the same controls here. So if I want to see how the flow of data from creating the product is coming into the product entity, I can see that flow of data over here directly. Okay. The other thing that I could just point out for you guys here is, of course, I can add my own operations. I can create my own commands, my own queries, my own services. I'm not limited at all to just using these CRUD out-the-box services. This is just what the accelerator sets up for me to save me a little bit of time, because that's a very common use case if you want to think about it like that. Another accelerator that you guys might find a little bit interesting here is on the find products. You can see that the find products is going to return us a list of product DTOs. Now, in a system which has tens of thousands of products, you don't want to do that. You don't want to go fetch out all 10,000 or 100,000 products in that system. You want to probably employ some kind of pagination. And so we've got accelerators for, like, those are very common use cases. So we'll typically have accelerators for things like that. So if I just say paginate over here, what that's going to do for me is it's essentially going to take this find product. It's going to paginate this with a page number, a size, and an order by. You can see that what it's returning for us over here is the page result with that order DTO. So that's just another example of an accelerator, just to give you guys a bit of a broader context around that. Now, if we push Control S or save at this point, Software Factory is going to kick off in the background. And we can see here's the changes that it wants to bring in. Now, of course, you can see that there's quite a lot of changes, a lot of code that Intent Architect wants to bring in order to realize those services, the commands, the handlers, and so on and so forth. I'm not going to go through all of that. I'm rather just going to look at some of the highlights. So let's take a look at the create order command. So you can see it's a very standard mediator-based create order command with its an I request, which returns a GUID. It's got the I command interface on it. That's just to make sure that the units of work patterns and things trigger correctly if you're familiar with this architecture and the way that it's set up with the mediator. And you can just see it's got the payload exactly as we stipulated and a constructor out the box there for us. We can take a look at the handler for this. And we can see that here's the handler. If you guys are familiar with the mediator pattern essentially is you're going to dispatch that command onto the mediator. It's going to run through a pipeline of behaviors. And then its ultimate destination is the request handler. And the request handler is where you will write your business logic. So all of your other cross-cutting concerns, things like security and logging, and so on and so forth, those can all be done as part of behaviors. And then ultimately your business logic doesn't have to be infected with a lot of those cross-cutting concerns. You can just focus on the business logic at hand, just for those of you who aren't familiar with the mediator pattern. All right, so this is ultimately, by the way, you can see this is business logic, right? And it's been implemented for us. So it's creating the order, and it's adding it to the repository, calling save changes, and returning the ID. And you may be wondering, well, where did that business logic pattern come from exactly? And let me just show you guys how this works in a bit more detail. So if we head back to the modules and we search for CRUD over here, we'll find this module over here called Mediator CRUD. I can uninstall that module. You'll see that it'll kick off the Software Factory automatically in the background. So we can just come back to this file and we can just watch it. And you see it updated for us instantly, or pretty quickly, and as part of that Software Factory execution. And what you can see here is that auto implementation of that business logic is no longer being applied. And what is remaining here is what we call the placeholder pattern, where we're essentially prompting the developer. We're saying, dear developer, you now need to go and write the implementation, the business logic implementation for the create order command handler. Now, what is important to keep in mind is that from an intent architect perspective, when it comes to automating predictable and repetitive code, you can automate anything that is predictable and repetitive, but you can't automate through the modules in the traditional sense, at least. You can't automate anything beyond that, right? So within this, and that's where things like, for example, the developer will always have to come in, or you can apply things like AI and so on and so forth. And I'll take you guys through some of those ideas a little bit later on. But within that spectrum of predictable and repetitive, the development team can also decide exactly what they want automated and what they don't. So if they don't want to automate the business logic inside of the handlers, and they want to have it so that the developers on the team will always write out the business logic, then they can just uninstall that module and they can always write it out themselves, right? So anywhere on that spectrum, the developers can decide exactly what they want to automate and what they don't. But of course, in this particular case, this logic is predictable and repetitive. So I can install a module like this mediator CRUD. It can kick off the software factory again, and it'll just bring that code right back in here for us, automatically, essentially writing out this business logic. The other thing that you guys may be wondering about, especially if this is the first time that you guys are seeing Intent Architect, is you may be wondering, what are those attributes over the method and over the class? These are what we call code management tags. They're essentially instructions for the code management system. And fundamentally what they are is they're empty attributes. They're just pure code metadata. They do absolutely nothing to the runtime. They're open source, of course. There's a publicly available NuGet package for them. And this is something that it is not a dependency at all. They're also completely optional, and I'll show you guys exactly what I mean by that a little bit later on. This is not a dependency from a code perspective whatsoever. This is just purely empty metadata, and is here to allow us to instruct the code management systems. And if you guys have questions about this, just know that I'm going to be doing a deep dive into these attributes and these tags a little bit later on. All right. If we're happy with all of this code here, like I said, I'm not going to go through all of it. We can go ahead and say apply changes. All of that code is now inside of our code base. So here's our orders. By the way, in here is our product service. So for those teams that are more familiar with, they're not familiar with the mediator pattern, this is the product service. This is, the very more traditional service approach and design paradigm, where you've got a service which implements a service interface, and you'll go with all of your operations and you'll go and implement them directly within that service as an operation. And both of these approaches, by the way, they both have their pros and cons at the end of the day. That's why, they're both supported fundamentally. All right. At this stage, we can also just hop back to the services. And just to close the loop here for you guys is you can see we get these. If I click on this, it's going to give me a suggestion. It's going to say, would you like to expose this as an HTTP endpoint? I'll say, yes, please. And what you can see that does is it goes and sets this little icon over here to show me that this is now exposed to the outside world as an HTTP service. And if I click on it, I can see exactly how it is being exposed. It's as a post, this is the root, this is its return type, and I can obviously go and override the success code if I want to on that front. I can also just do that for all of these in one go. So I can just, make all of them exposed over there. And for the service, I can do the same, right? And I'll just expose all of those. So now I've taken all of the service I've created, and I'm exposing those all as HTTP endpoints. And if I push Control S or save, and I rerun the software factory execution, we can just wait for that to come up. And what you can see is rolling out for me right now is it's rolling out the controller pattern. So I've got a controller pattern installed. If I had a fast endpoints pattern installed, I would have a whole bunch of fast endpoints. So it really depends on what pattern we have installed. And if we wanted to switch from one to the other, especially at the infrastructure layer, you can absolutely do that. And you could do that at any point in the development lifecycle. All right, so let's take a look at our controllers. If you guys are using a mediator pattern inside of your applications, I'm sure this is exactly what it looks like inside of your application. You're injecting in the mediator. And for example, on the create order command, we take the command, we dispatch it onto the send, and we get the result back, which is the ID, if you guys recall from earlier, and we return back the 201 with the ID as the result. For the delete, we take the ID from the root, okay? We inline construct the command, dispatch it, and return the 200 if it is successful, and so on and so forth, right? So this is just a very, very straightforward controller pattern. You'll see that there's absolutely no business logic in this layer. That's part of a clean architecture. You never want to see business logic typically in your infrastructure layers, just for the simple reason that you may have multiple entry points into your application. You may have HTTP endpoints, you may have gRPC endpoints, you may have messages that you're receiving from the bus that are maybe all triggering the same command. You do not want to have to duplicate that business logic across all of those different entry points, right? So that's all part of the clean architecture and the reason why those things are done that way. We can go ahead and say apply those. We can come back to our code base, and now inside of a controller folder, there are our two controllers. And at this stage, we should be able to say compile. And it's launching up. All right, just jump to the other monitor. And here is our Swagger UI, right? So if you guys, one thing I didn't point out for you guys a bit earlier is if we take a look at the settings over here and we scroll a bit down, under the database settings, so these settings all come in depending on what modules you install. The default database setting is set to in-memory when you install the clean architecture. So we could pick whatever kind of database approach we want to take on here from an entity framework perspective. But because we've got an in-memory database, what that means is that we can actually hit these endpoints directly and everything will just work. So let's go ahead and do that. Let's go create a new product. We'll call it our webinar product of some sort. And I'll just use just some random developer description over there. And we'll make the price 1,000, whatever currency we're working with. And I can go ahead and say execute. And there's our 201 with our ID, as we would expect. So we can just copy that ID over here. We can come to the order and we can try it out. And you can see it's already got a single order line over here. So we'll just go and replace this ID with the product ID. We'll say 10 units, 1,000 euros, 10% discount. And we'll just go ahead and give it some random order number, execute that. There's our 201. There's our ID. We can execute that again, execute it again. So we've got 3 orders that we've created, and I can go to my API, my API/orders, try it out, and it'll fetch out all of those orders for us, right? Now, one thing that you guys may notice over here is that the product name is, in fact, resolving the webinar product and everything exactly as we would expect. And one thing that Intent Architect does really, really well is it connects the developer to the code base from the design perspective really superbly. So let me just quickly show you guys how this works. So we've got a feature inside of Intent Architect called Open in IDE. And if you hover over the Open in IDE, what it'll show you is it'll show you all of the files that are related to this particular piece of metadata, this part of your design, okay? And so we can see that for the command here, the create order command, it's got the following code files, this create order command, the handler, a validator. For the order itself, we can see that we've got the entity order, we've got the repository interface, we've got the order configuration, and we've got the order repository concrete over there. On the service, it's the controller, the product service, and the interface, and so on and so forth, right? And so we may be curious, where did this code ultimately, how does this actually work inside of the code? So if I just go here and I search for the order, let's just look for that order DTO. All right, and on this order DTO, there you can see the order line. And on that order line over here, we can see that this is where we did all of that work here. I can go to the Open in IDE and I can click on the DTO itself. And what you can see that does for me is it's going to, I can see we're still running the app here. Let's just shut that down. It's going to open up the DTO itself, and we can see there's all the fields that are coming in. We can see it's got a static constructor. So this is just something very useful to avoid bugs, if you guys are familiar with this pattern. And this is the order mapper code, right? So if we're curious about how this is all fitting together, we can just dive right there into the code to see exactly how it's all working. And this is order mapper, but you could any mapping system, even direct mappings, will make super light work of this. It's very, very, very straightforward and easy to do. Okay, so at this stage, what I want to do with you guys is I want to do another quick iteration, and then we could jump into the next stage of the demo. So the reason I want to do another iteration with you guys is when it comes to building our software systems, we're all building systems typically in an agile approach, right? So not many teams get to build a piece of software, give it to the clients, and forget about it for the rest of their life. There's always this constant stream of new updates, new requirements, new use cases, bugs, features, et cetera, that must come in on a regular basis. So let's just do a quick iteration just so that you guys can get a feel for how this all fits together. All right, so I'm going to go here and let's just say that the business comes to me and says, Gareth, we're happy with our ordering system, but we need to know who the buyers are of these orders. Okay, that's not a problem. I'm going to create an entity here called buyer. And let's say they tell me these are people. So that probably means that they have a name and a surname and an email address, for example. And maybe the business says, well, we also want to be able to activate and deactivate these buyers. Okay, that's not a problem. We can just create an isActive field over here, which is a Boolean. And they also tell me, Gareth, we also need to know where they live because we'll be delivering the orders to them, or we want to be able to bill at a certain address or whatever it is. So I'll just spice this up and I'll use a value object pattern for us to describe the address, and I'll give it a line 1 and a line 2 and maybe a city and a postal code, for example. There we go. And we can just set up the relationships here. So the default relationship for value objects is 1-to-1, and we can go here and we can create a many-to-one relationship between our order and our buyer itself. So that our order must have a buyer. We can, of course, say that an order may have a buyer or not. Okay, just set that to nullable. And then we can also just set, like, for example, these constraints here. So on the name and the surname, we can set some of the text constraints, like 30 characters maximum, maybe on the email address, make it 256, On the line 1, line 2, city, let's just make it those 3. We can give them a max character length of 200. And on the postal code, we can make that 20. And if we say save at this point, Software Factory is going to run. And what you can see it's going to do for us over here is it's going to shift our existing code base to this new design, right? Now, this is a very simple shift. But from an intent architect perspective, it really doesn't matter how complex a shift you actually want to do, right? You could introduce inheritance, you could like move all your data around within the system, and you could just reshift your whole application from a domain perspective. And intent architect, from when it reruns the software factory execution, it will just shift the underlying code base now perfectly into accordance with that new domain. Now, the one thing I can just mention on that front is while we're able to get the code base perfectly in sync with this new design, the one thing that you will still have to deal with as developers, just so that it's 100% clear, is you'll still have to manage the migration of the data, right? That, unfortunately, migrating data, especially if you're doing complex shifting around of your designs, if you've got a live system and you need to migrate that data, that is unfortunately not predictable and repetitive. And as much as I wish we could automate that stuff, maybe one day we figure out a way to do it, that's something that the developers are going to have to take care of themselves, right? So just to make sure that the data does, in fact, get migrated appropriately. All right, so let's just take a quick look around here, not to spend too long. So we got the buyer getting added to the entity. There's the DB context for the buyer coming in on the DB for the DB context. This is the order configuration. So there's our relationship being set up correctly. And here's the buyer configuration itself. One thing I could point out is that you'll see there that those constraints, those database constraints that we put in, or at least those data constraints that we put in the domain are actually being applied to our database from an entity framework perspective. All right, so if we're happy with this, we can say apply changes, and all of that software has now been fixed, and now all of that code is inside of the code base. All right, so just to close the loop here then, we can jump into the services again. You can see we just got a bit of a warning over here. Let's take a quick look at this warning. It's showing me that there's a warning in the mapping. All right, so the buyer ID is essentially just wasn't being set over there. It was just giving me a warning. So I've just gone and created that. By the way, that warning that we got over there, you wouldn't have picked that up at runtime. That would have been something, sorry, you wouldn't have picked that up at compile time. You would have only been able to pick that up at runtime. And so that's something that we've been able to do with Intent Architect, is we've also been able to find ways to validate certain scenarios so that those things are picked up before they even go into the code base, and would only potentially get picked up at runtime. And as you guys know, if that gets missed by the developers and then maybe missed by the QA or UAT team, then we all know where that gets picked up later, right? Okay, so we're going to go ahead and apply that. Next, what I'm going to do is I'm going to create some CRUD CQRS operations just to close the loop here for the buyer. And we can go ahead over here and we can say exposes HTTP endpoints and say save, and we can run the software factory execution. And all of that code is being rolled out of here: controllers, commands, handlers. The one thing that you guys may find interesting is that you'll notice that the validators are also ensuring that those domain constraints, those data constraints that we set forward, are in fact being validated, so that we don't actually go and have an exception within the database or the EF. We can go ahead and say apply changes, and all of this code is now inside the code base. And then just so that you guys don't get the impression that we're limited to CRUD related aspects of the system, of creating out our software systems, we can go ahead and create our own command here. Maybe I want to have an activate buyer command. Maybe I want to activate the buyers by ID. So I'll just search for these guys by ID. And I want to update essentially the entity when I do this. I can say done over there. Maybe same for the queries. I want to create my own query over here. So I'll have a get buyer statistics query. All right. And let's say that this will return us a special DTO called buyer statistics DTO. And on this DTO, we'll have the buyer ID, which I'll make a GUID. And the buyer name, which we can leave as a string, and maybe the number of orders that this buyer has had with us. And what is the average cart value, which is a decimal, right? And we could just also specify here that this query will in fact return these statistics. We'll be able to find these guys by ID, which is a GUID. And I can also then just say that I can indicate to Intent Architect that I will in fact be querying the buyers to work this stuff out. Okay, so we can say save at this point. In fact, hold on, I just want to actually go and expose these as HTTP endpoints just so you guys can see how this would work. There we go. And we can say save, run the software factory execution. And what you can see that's going to do for us, just so you guys get an idea here, it's going to create us our endpoint. So there's our activate endpoint for the buyers. There's our statistics endpoint. So we're getting the ID as from the query in this case, dispatch the query, get back the result, which is this DTO, and return it as a 200. There's our query. There's our DTO. Here's our handler. And if we take a look at the handler, there you can see we're back to this, dear developer, you now need to go and write your own implementation of this code here. Now, this is, of course, the reason that this is not implemented for us is because getting statistics out of a system is not predictable and repetitive, right? And so this really needs to ultimately fall to the developer to go and write this particular code to go and fetch out these statistics in a performant manner. And this is where we can leverage all kinds of things, like we can leverage AI or whatever else we can find out there. But ultimately, it's going to fall to the responsibility of a developer to make sure that this is done correctly. Now, this is, by the way, what we call the nuance of the application. And whenever we engage with teams to onboard them with an intent architect, there are two things that we want them to be able to focus on. The first is we want the teams to be able to focus on, I'm just going to go ahead and apply these changes. We want them to be able to focus on the design of the system, because as you guys probably know, you can have the perfect architecture, but if you mess up the design, that is a really, really expensive form of technical debt if you don't correct it very quickly, especially for new features and things that come down the line. So we want teams to be able to focus on the design just because of how massively important the design of the system is. And the other thing that we want teams to be able to focus on is the nuance of the application, because these are the things that actually make a difference to the business. And what we see a lot of teams do is, particularly on the design side, is they really like to do things like this, where they'll create comments with, for example, reasons why. And they'll capture things like, the reason we designed the system this way is because, and they'll go and capture some reason why they've gone and designed the system this particular way, and we can go and just connect this up to exactly which part of the system, part of the design in the system that we're referring to. And this is something that we see a lot of teams do because quite frankly, it's just like 100 times better than a code comment, right? If you put a code comment in the code, it's super easy to miss it. It gets lost. It hardly ever gets updated. These comments here directly in the design of the system are visible to everybody, even potentially business stakeholders. And especially on larger projects that last for a lot longer, the reasons why certain design decisions were made is one of the first pieces of information that gets lost. And it's also one of those things that down the line, because the team forgets, I at least know for myself, after about a year, I start to forget why we made certain design decisions. That you don't end up making a bad choice later on because you forgot why you did what you did the first time around, right? And I've seen that mistake happen many, many times as well. This is a great way for us to track those reasons. All right, so at this point, I can also just rerun the software factory execution. And once it finishes running, we end up in a very important state where it says all good, no changes. And this is a really important state because what it means is that when we're looking at the design of our system, we are in fact looking at the truth of the system, right? And so that's very, very important because that means that any developer who's looking at this does not need to go rummage through the code base to understand the designer system. They can see the exact design as in they know with 100% certainty in their code base. For example, in this one exists a product, an order line, an order, a buyer, an address with these fields, with these relationships, and that it's all implemented perfectly according to the architecture and the patterns that we picked as a team when we decided what modules we wanted to run for this particular application. All right, now at this stage, guys, when we do the demo, we oftentimes get a lot of questions. A very, very common question is, okay, great, I've seen Intent Architect writing a lot of the code. What happens if I want to go and do some customizations? I want to do some customizations in, for example, a buyer. I want to be able to change the way that, for example, this business logic works or whatever the case is. That's a very, very common question. And that's exactly where I'm going to go next. And that's exactly what I'm going to show you guys how we can do is those customizations. The other questions that we oftentimes get is, if I have an existing database, can I import that database into Intent Architect? The answer is yes, absolutely. We have modules inside of Intent Architect for doing all kinds of imports. And so you can import, SQL Server, OpenAPI documents, and all those kinds of things. You can even import from code bases and so on and so forth. So if you're trying to plug Intent Architect into an existing system or doing a rewrite, for example, you can import all of those designs directly into the system. And then also a very, very common question we get is, can you apply intent architect to existing systems? And that's a bit of a deep question, and we don't even have time to go into that. But the short answer is yes, you can apply it to existing systems. It does depend on the system. If the system is built quite in a very standardized way, it's often quite easy to plug intent architect in, especially if you can quite quickly create parity between the architecture and the modules that you're installing. So if they're following, for example, industry best practices, it's usually very straightforward to plug intent architect in. But if that code base is chaotic and has huge amounts of entropy and it's basically a big spaghetti ball, it's oftentimes just better to rewrite it, because with intent architect, we can rewrite that system in a fraction of the time it would typically take. So those are just some very common questions we typically get at this stage in our demos. So I hope that gives you guys a bit more insight. All right, so last thing I want to run into with you guys here is what happens if we want to do these customizations. So very simple example, especially a question we get from teams when they're new to intent architect is, can I bring in and create my own classes, my own helper methods, utility classes, services, and so on and so forth? The answer is yes, of course we can do that. We can go ahead and create a new class as an example, and I can create a new utility class called my helper. And this could be a public static class, for example. Maybe it's a public static void help me method. And this method will help me, right? So do something. If I come back to intent architect and I rerun the software factory execution, what you guys will notice is that it still says all good, no changes. So it's just not aware of this code, right? So any code that intent architect is not aware of, it's just not going to touch, right? So that's also part of plugging into existing systems, is we don't have to touch all of the code. We can just touch the parts of the code that we want, like the new features and things like that. So that's a very simple example. The next example is because intent architect doesn't know about this code, but what happens if we want to make code changes that intent architect does know about? And just as a quick aside here, is part of our core philosophy from an intent architect and code generation perspective is that intent architect will never ever get in the way of the developer, right? So if there's anything that a development team is doing, and that's another question that we sometimes get from time to time, is can we still do this and can we still do that, and all these different things that the team is doing that's quite nuanced. Intent architect will never ever stop the team from doing any of those things, right? We've designed this platform in such a way that it should only ever bring upside, and it's one of our core principles and core philosophies is that it should only ever add value to the developers by automating the work and the boilerplate work coding that they would have had to do themselves, and getting that work done for them essentially, and just taking that off their plates. But anything else that you guys would like to be able to do, just know that you can absolutely do that and control it. So that's it. I'm going to be showing you guys a lot more of that in a bit more detail now as part of this. Now, let's say we want to actually make some customizations to this code. This is code that intent architect does know about. So let's jump right in here. Let's say we want to do something like, if the request email address ends with @intentarchitect.com, I'm going to throw a new exception. And let's say I want to have this exception is going to say no intent architect users allowed to buy from us. Okay. So someone just hates us and they never want us to be a buyer. I'm also just going to call my helper over here. So my helper.help me. Okay. And we can push save, and we can come back to intent architect, and we can see that it's already picked up this change. And it's also warning us here that this is a destructive change. And what that means is that we really want to see what's going on here, because intent architect is essentially warning us that this change, if we say apply changes, could in fact remove code that we created as developers. And so we definitely want to take a look at here. You can see exactly why this was flagged as a destructive change, because intent architect essentially wants to delete all of my custom code. Now, if you guys have experience with code automation systems, you'll know that this is usually the moment where those code generation systems go from being this asset to being a massive liability. And that's really because we are either faced with two options, right? Either one, typically speaking, we would have to turn off the automation system, so we would lose all the power that it brings to the table into the future, but at least we'd be able to keep our code where we want it. The alternative is that we can convolute our code base, or at least try to separate out the fully automated code from the customizations, and we can use things like partial methods and partial classes and things like that. And that essentially convolutes our code base really, really quickly. I've been working in code generation pretty much my entire career. I can tell you I've been down that path, and that's a very, very messy path, and very quickly that code base becomes unmanageable without the automation system. And you're also essentially engaging in a bit of an arms race with the automation system, because with your need to customize. And I was on a project many, many years ago where we came to a bit of a crossroads in the mature stages of that project, where we actually couldn't make certain changes quite easily, certain customizations, and that became hugely expensive for the clients. And let's put it this way, they just weren't very happy about that. All right, and neither of those options are really uh, acceptable from our perspective at Intent Architect, and that's where these code management systems come into play. Now, before I get into using these, I did mention earlier that they're optional, so let me just quickly show you what I mean by that. If we head over to the settings and we scroll to the bottom, you'll see that we've got some Roslyn settings over here. And you can see that we've got different, under the default tag mode, it is explicit. I can just switch this to implicit mode, and I can say save, and we can rerun the software factory execution, and we can just watch what it wants to do here. And what you can see it wants to do here is it wants to strip out these instructions. Now, the reason it wants to do that is because in implicit mode, and by the way, you see that it wants to do this in across the entire code base, is that in implicit mode, what we're essentially telling Intent Architect is that if the instruction is the default instruction, which all of these are, you don't need to add it to the code base. So essentially, they can all be removed. The only instructions that we would have to keep in the code base are the deviations from the default instruction. So all of wherever we make changes to what those rules are, those are the only instructions that we'd have to still keep in the system. And then we also have this final option over here called template only. And this is an option which essentially will strip out all instructions from the code base completely end to end. And we have this option here available as part of our promise that there is absolutely zero lock-in to Intent Architect. Because if a development team wants to completely remove any trace of Intent Architect in that system, they can essentially do that in a matter of a few seconds by running it in template-only mode, and all of those code management tags will simply be removed from the code base. This has data loss in it, because any deviations would be lost as part of that. But between implicit and explicit mode, there is no data loss, and so teams can jump between those. All right, one thing I can just mention is that we do recommend, however, that teams start in explicit mode, and a simple reason for that is because then everything is explicit, and it's easy for the teams to see what the default instruction is. All right, so with that out the way, let's get into actually using these instructions. If you guys are familiar with abstract syntax tree notation, you'll know that everything between these two curly braces is what they call the body of the method. And you'll see that there's an instruction here that says body is equal to fully. And I can just go and change this. Just a recap, this is the code base, this is the projection. So inside of the code base, I can go and change this to ignore. I can say save. And what you'll see is that it immediately goes to keeping my code in the projection. If I change this back to fully, it'll go back to deleting my code. And the reason this is happening in real time is because we've got an active software factory in execution. It's watching the code base. If a change happens to the code base, it will rerun that change through, it'll reprocess that through the algorithms, and will update the projection for us pretty much in real time. I think it takes about 100 milliseconds for this update. So we as developers get this instant feedback loop into what our changes, how they would affect the projection if we say apply changes inside of the software factory execution. So what I'm going to do here is, in this case, maybe I just want to ignore this code. And what I've told Intent Architect, and I'm sure this is pretty intuitive for you guys, is that everything between these two curly braces is now, in fact, ignored by Intent Architect. And I've essentially said, I will take over this as a developer, and I will manage any changes that needs to happen to this code going forward. So any code changes, I will take care of those in here. So that's the first example. Let me show you guys another example. Maybe we want to separate this into a separate method called private void do something. And let's say that this do something method is going to just do something for me. And I want to call this method from here. I'm going to call do something, right? And I can say save. Of course, this is to be expected. You can see it's keeping this code over here. That I'm sure would be expected for you guys because of the ignore over there. I've told it to ignore everything there. But why did it keep this code? That's because of the merge instruction, right? And one thing I could just mention here is that the code management systems are incredibly simple. They are super, 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 super simple, right? Because there are only 3 instructions that we can apply to any piece of code within the system. And you guys have already seen them, right? So the first instruction is fully. And what that tells Intent Architect is that Intent Architect is allowed to add code, it's allowed to update code, and it's allowed to delete any code that's not part of the original pattern, right? As you can see here, that's exactly what it's doing. Then we've got ignore, which basically tells Intent Architect, as we saw earlier, that it under no circumstances must touch this code going forward. This is for the developer to manage. So I've taken it over essentially. And then we have the final option, which is merge. And what merge tells Intent Architect is that Intent Architect is allowed to add code, it's allowed to update code, but it's not allowed to delete my code. It's allowed to delete its code, as in code that it knows the automation system wrote, but it's not allowed to delete code that the developers wrote, right? So here you can see that all of this code is being left alone here. And this code is actually still, in fact, under management, and so is this code, and this code is being ignored, and so is that. And so if we came back, and that's very, very useful, because if we came back to the services designer, and we came into our create buyer, and we came back into how the flow of data is being stipulated, we can say, well, for whatever reason, we don't want to set the address on the buyer. We can say save, rerun the software factory execution, and we can just watch for the update. And what you can see is that it's going to now remove the setting of the address, because that's what we told it to do, but it's going to quite happily keep my code, at least the developer's code here. And so the merge systems are really, really smart. They know the difference. They know what is developer code, and they know what is code that was written by Intent Architect at that very, very fine-grained level of control. The other thing, just for completion's sake, that I could show you guys here is, of course, you can also do things like this. I could switch it to fully mode, and I could just put a little comment over here. If I just wanted to intent ignore this one line of code, right? And I can apply this ignore anywhere I want. And you can see, so it'll just ignore that statement over there. Same for this one if I want, and so on and so forth. I can even ignore code that Intent Architect was managing. And so I could just take over everything over here, and I could put these individual lines of code. And the reason I wanted to show this to you guys is because, of course, and I can just remove all of these, and we can switch it back to merge mode if we want, is because what you can see is that, and this is coming back to that philosophy point I was making earlier, is that we have as developers, full control of our code base, all the way from the individual line of code perspective, all the way through to the file perspective, right? So we have always got full control, and that's very, very core to our philosophy. Now, one thing I can also just show you guys here is that we can change instructions where we see them. So I could change this to fully, for example. What that's going to do now is, of course, it's going to delete this code because, as you guys probably can anticipate, this is not part of the original pattern, and fully mode means that I can remove that. And I can also add instructions wherever I'd like throughout the code base. So I can say intent ignore over here, and it'll keep that code for me going forward, right? So I've got this full control at every level. And when we're building applications, one thing that is worth mentioning here is that whenever we build applications, we absolutely want to keep as much of the code base under full management with Intent Architect as we can. And the simple reason for that is because then that code can be upgraded later on. So think the automapper pattern upgrade that I mentioned earlier and things like that. So let me give you guys a very simple example of something like that. Like, let's say we want to do something super simple. Like, we just want to change the cross-cutting concern for example, our API security. We want to change our API security to be from unsecured by default to be secured by default. I can push save. We can rerun the software factory execution. And what this is going to do for us is it's going to update all of our controllers. And here we can see that what it's going to do is it's going to update our OpenAPI metadata for us over here, as well as put the authorize on it. And the reason it can do all of this work for us in this very simple example, because of course this could be a lot more complex, is it's able to do this because this code is in fact under full management with Intent Architect, right? Now, also just for completion's sake here, I can also just show you guys, I can always add intent ignore wherever I want, all right? And here you can see I've just gone ahead and ignored the create buyer over there, or I could put this on the delete. And if I wanted to, I can, I can do whatever I want in here. And it'll keep that code going forward. So this is just to show you guys I can apply these wherever I want. Now, you may be wondering, do I need to apply intent ignore to disable security? Of course, it's much better done from a designer perspective. So if we wanted to, for example, make this create by command unsecure, I could just unsecure it over here. Now, what I really like about this is that, especially as an architect, I get a big red unsecure icon on the designer that highlights to me instantly that this is now actually an unsecure endpoint, whereas the rest of them are in fact secured. So that's obviously something that's very, very useful, is having this metadata and this visibility makes sure that you can spot anomalies and weird things. Like maybe you'd want your team to give you a comment as to why this is unsecured, especially if it's not obvious, right? But if we come back here, we'll see that the allow anonymous has been applied for us automatically. All right, we can go ahead and say apply changes to all of those. And that's really just to give you guys an idea of the code management. Now, one thing that a very common question we get when it comes to code management is maybe you have a team of maybe less experienced developers, maybe there's some graduates or some juniors and so on and so forth. And maybe there's a concern amongst the team that the developers may start to deviate from the architecture, and you're worried that there could be a lot of intent ignores going all over the place, and maybe that's not an intention on the team. So one thing that intent architect can also do for teams is it can actually track where in the system the team has deviated from the underlying architecture. And here you can see right now we've actually only got 2 deviations in our system, and we can take a look at what these deviations are. So the first deviation here we can see is this one that I added just a minute ago with the intent ignore. So on the right here is what I did, and on the left is what intent architect wants to do. And here you can see I've got my I could do whatever I want in here that I just typed out a minute ago. And the other deviation that we've got over here is all this work that we did a little bit earlier, where we added in our own customization. Now, as an architect on the project, I could look at this and I could say, well, this actually makes perfect sense. This is exactly where I want this business logic to be placed. And so I'm going to go ahead and I'm going to say, approve this deviation. And it's going to show here, well, Gareth approved this deviation. This is when he did it. And if I want, I could also capture some notes about this. Maybe me approving this deviation is something that I want to take note of for future. So I can go and create some notes if I want around that. Similarly, for the controller, I could look at this and I could say, well, geez, actually, in fact, this makes absolutely no sense. You should not have this ignore over here. So I'm just going to remove that. You'll see it'll automatically correct, and it's going to remove that deviation for us right away. Okay. So one thing I could also just mention here is that the software factory executions, we have a CLI version of the software factory execution, and what that means is that, and this is something that is recommended practice with Intent Architect, is that you can plug this CLI into your CI/CD pipelines. And what that can do for you is 2 things. The first is that it'll automatically validate that the designs of your system are in fact in perfect sync with your code base. That's obviously very, very key, because that means that you can focus on the designs of your system without wondering whether the code base is in fact in sync or not. And the second thing that could do is you can automate a huge amount. So that by itself will automate a lot of the governance on your projects, but you can also take that one step further and you can fail builds, for example, in the late stages, like before they go to UAT or before they go into production, if there are deviations that haven't been approved by somebody, right? And so that obviously means that you can lighten the load, and this is something that we see a lot of teams able to do. You can lighten the load on the pull requests, where the senior developers don't have to spend as much time policing the architecture and the standards, because a lot of that stuff is essentially automatically enforced, and you can have the check-in of the deviations happen on a basis that is not so cumbersome for those senior developers, and that's something that we've seen can reduce something like 80% at least of the policing work that those senior guys are having to do, which is obviously great, because then the senior developers can focus on senior work, which is really what I'm sure for most of them they would prefer to be focusing on. So guys, that is the high-level introduction that I wanted to take you guys through. I did promise you guys that at this end of this webinar today, I was going to show you guys a quick sneak peek into some of the AI capabilities that we can integrate with Intent Architect. And so what I'm going to do to get in there is I'm going to quickly launch up one of our developer builds for the 4.5 of Intent Architect. This will be coming out hopefully as soon as possible. And we can just open up our webinar over here. And we could jump right in. I'm going to just close some of these here. Let's just go to our modules. And I'm going to browse for a module here, which is in pre-release at the moment. This is open source. So if you guys are curious about this module, you can go check it out. Called intent.ai.auto implementation. I'm going to install this module. You can see our services just wants to reload. And what this module it gives me here is it adds an extra option, which I'm sure you guys would have seen didn't exist earlier, called implement with AI. Right? And if I click this, what you'll see it does for me is it actually launches a task over here. Now, this is one of the joys about AI, is that it can take a bit of time. And so to get the prompt to go through this. And this is using GPT-4o. And this is, by the way, this is not something that's built into Intent Architect at all. This is all built into this module. So just as a reminder, Intent Architect is a platform. And so ultimately, as a platform, you can plug all kinds of processes and services into Intent Architect and trigger them from inside of the Intent Architect ecosystem. And this is just a simple example of us doing that. And the new capability that I'm showing you guys here is the ability to host these processes inside of a hosted task where we can actually make changes to the underlying code base. And as you can see here, this AI system, which if we took a look here, here you can see a little bit of the prompt. This is all going through semantic kernel, as you guys would expect. We can see that it actually is listing out 3 changes for me over here to our buyer statistics. And we can go take a look at what these changes are. And here you can see that it is actually going ahead and automating the implementation of this statistics method. So I don't know if you guys took a little bit of a moment to think about how you would actually implement the getting of this buyer statistics. You would have to, obviously, you probably want to fetch out these statistics in a performant manner. You would not want to fetch out all of the orders and all of the order lines and all of that information. You wouldn't want to fetch that all out into memory and then chug it all and then pass it back. You would want to get the database to do that. So here you can see the AI system is a little bit, it's smart. We've given it a good prompt. We've told it about the architecture. We've told it the information that it needs to know. And so GPT-4o is able to actually deliver here. And you can see what it's doing is it's fetching out a buyer. It's dispatching onto the order repository. It's fetching out the count of those orders. It's fetching out the sum of the cart values. And then it's going to get us the average of those, and it's going to return this. Now, each time you run this, it's going to be different. This is non-deterministic. AI is non-deterministic fundamentally, whereas the modules, in their more typical sense, and pattern reuse is completely deterministic. And so the combination of those two, AI plus IA, is kind of another way we want to think about it, is we can actually plug a huge amount of the gaps in our software development process. Now, of course, curious to see what the AI system decided to do under the hood. So here you can see on our order repository, it's gone ahead and automatically gone and created these 2 methods. Sometimes it creates one method. I've seen it do all kinds of things with this particular example. And here you can see that it's automatically gone, and this is, I would say, 100% correct over there. And this one over here, I would have to just look at it a bit more carefully, but this is the whole point. This is why you can't just leave an AI system to do a lot of the stuff, but you see that you'll have to go and take a look at exactly what it's doing here to be sure that it didn't just get a little confused. But it's already done a huge amount of the lifting for us, and I can tell you I wouldn't have done that in 30 seconds, even if I had a very, very clear picture of what I would have needed to do this. And that's really the essence of how we accelerate teams, just by the way, is we look to take those 5-minute jobs and turn them into 30-second jobs. We take those 1-hour jobs and turn them into 5-minute jobs. We take those 1-day jobs and turn those into 10-minute or 1-hour jobs, and those 1-week jobs and turn them into a day job, and so on and so forth. And this is how we're able to accelerate software development so dramatically. Of course, with a developer at the steering wheel at every step of the way, as we can see here. All right, so we can go ahead and say apply changes. And of course, you could do this anywhere, right? You can kick these things off. We can actually also just take a look here as to whether that even worked for us. I'm going to just try kick off a compilation because that'll just be the shortcut. So what's nice here is you can see everything's compiling. It's got one little issue over here where it's probably just struggling to convert some decimal from the looks of it to, I'm not going to fix it, but that'll be easy to fix for us over here. But we can also trigger these off multiple at a time. So you could be saying to yourself, well, auto implement the activates, auto implement the statistics, and you could trigger these all off in every direction. You could trigger, as many as you want, as long as your AI provider doesn't stop you, it doesn't throttle you in any way. You can trigger off as many of these things as you want. So you could essentially think of it like kicking off prompt windows integrated through the code base all over the place as and where you need to, right, to build out your functionality. The one last thing I can just mention here is that we can just see what the activate buyer wants to do over there. Yeah, so it's just going to activate the buyer, right? That's that was a simple one, right? Already not too hard for the AI system. One thing I could just mention here is I haven't showed this to a lot of people at this point. This is all very, very new stuff, so I hope you guys are liking what you see. But one of the comments that one of the developers made was, "Wow, that's pretty scary," right? And I actually wanted to just mention that our view on this is that and this is something we've seen, like we help teams accelerate their software development massively, way more than AI is able to do it at this point. And we've spoken to a lot of these huge consultancies, and they've told us, AI is giving them about a 12% improvement in velocity, maybe up to 15%, depending on how things are going. And we're able to go much, much faster than that. And what we've seen is that there is the appetite and the desire for software from businesses is in far excess of what we as developers can provide, right? We are not even close to plugging the gap in what the businesses out there desire in terms of their software applications. And I don't think that we're going to get close to plugging that gap anytime soon in the next few years, right? It'd probably only be really plugged by the point that we can create software at the speed of thought. And so that's really what I wanted to just, that's our opinion at this point, is that this is not something that should be worried about too much from a software development perspective. The appetite for software is in far more excess than we could ever achieve as developers, at least with the tools that we've got at this point. And so it's really not something that we see as a worry, at least in terms of putting ourselves out of a job or anything like that. We don't see that happening. At least that's our opinion at this point. We'll see how well this video ages in the next decade. So guys, I just want to thank you for sticking with us and for the full duration. I know that this ran a little bit over. I wasn't sure exactly how long this was going to take, but we got through it all. And I just want to thank everybody for taking the time today. And I hope you enjoyed the webinar. And please give us a rating. Let us know what you guys think. I'm going to just quickly share a QR code here with you guys. If you can just go to that QR code and tell us what you thought of this particular webinar. I really appreciate that. Great, guys. That's all from me today. Thank you very much for your time again, and all the best. Till the next one.